So just a quick check whether, recording is started. Yeah, welcome to a development meeting of today. We have several topics, and we are just after an onboarding with new developers that we very welcome today. And yes, we already had some discussions about RF frequencies and the famous mystery in the L-band. And before we go into updates, what happened the last days, I just want to give you a short note on the enclosures are now shipped. They're in shipment. Tommy, you may say hooray. And we are about to order the next batch for the next batch production soon. So we hope that this enclosure production goes into a rolling mode, and we can.
So somebody ordered one in the next batch today. How long before they get the next one?
Yeah, if today, I would say 3 to 4 weeks. Okay. So the first 15 had to wait longer. we waited for a year, okay? Just to give you a perspective, okay? So to wait 4 weeks is quite okay. Yeah. I come back to you, Tommy, to your last question. L-band and the question, what questions shall we collect and to ask that person? Yeah, any ideas of questions? Are we talking with him about passive radar, RF in a broad spectrum, or L-band only? What is the goal?
Yeah, it's definitely, we need to isolate all of that, but he's open to discussing anything.
Okay.
He'll give us all the feedback as far as the antennas that they're building, because I talked to him about that as well.
Mm-hmm.
They're building another giant dish. They're building they're building a new observation deck in Las Vegas next to Area 51.
Oh, do they?
I'm not sure the size because we didn't discuss that, but yeah, they're very open to discussing that with us. Everything that they're doing, they will share with us.
Mm-hmm. Okay.
He's working for the Very Large Array project, or okay, yeah. So he mainly stays at Socorro.
Yeah.
Okay.
So any questions we can come up with to ask. I mean, I've already talked to him about the 1.6,
mm-hmm.
and he wants to talk to Eric about it. So I'm introducing him to Eric at the Skinwalker Ranch.
Mm-hmm.
But he didn't. Immediately speaking, he didn't have anything to add to that. There wasn't anything out of normal for him. He was just asking, where did you get this number and things like that. So
mm-hmm.
I explained to him how he got it, and so he's looking into it himself right now.
Mm-hmm. Mm-hmm.
But nothing when I mentioned it was out of the ordinary. He didn't say, "Oh, really? Wow!" It wasn't like anything like that.
Mm-hmm.
So it seemed to be new to him as well.
Mm-hmm. Interesting. Okay. So why not collect those kind of questions and drop them to you on, for example, Signal? Would that work, or do you prefer on Discord?
Let's do it on L-band. I can record it all.
Okay.
I can also go back and read it, and everybody else can see if we're not stepping on each other's toes and asking the same question.
Good point. Okay, we drop questions on L-band and we address Tommy so that he knows about it.
Yeah.
Okay. One question to addressing people, just a question about Discord. I've seen sometimes that people use the ampersand and then the name and it did not create a link. True? Is this true? Tommy, is this true for you?
Yeah, I've seen it, yeah.
Yeah, okay, I have to go after that. So that should work. So addressing someone should create a link so that a notification is created. Okay. Yo, who wants to begin? Let's talk about training material for a couple of minutes. Yanni, can you give us a short update if something happened the last week?
Yeah, so we had another 1,000 images, and one of our volunteers sorted them
Already? Okay.
already. Yeah,
Wow.
and now we still wait for more images actually for training. So the last uh, my last status on that was that Lionel wanted to Dockerize the simple tracker,
Mm-hmm.
and I think he couldn't do it yet. So
Mm-hmm.
I'm still waiting on that one. And what I did today is I did a first test with the images that we already have. So we have about 1,500 images of birds and about 1,500 images of planes.
Mm-hmm.
So I tried to use these images for first training of this YOLO V4 model. And that first try did not work out. So, and I think it's a case of sort of garbage in, garbage out. So I went through the test or training images again, and I found a couple of images, or quite a few images, which were empty, completely empty,
Mm-hmm.
and then quite a few images that were just small, very small blobs where you really couldn't identify anything. And I think that was the problem. So when I trained the model, it actually recognized everything as a bird. So, and that's not good. So, um, we need to refine the training images. That's something that I did today, but I didn't have the time to run the training again. So it takes a couple of hours. So
Mm-hmm.
that's my plan for the next iteration.
Okay. So
Yeah.
brings me to a basic question we had last weekend. The discussion about I just give the ones who are unfamiliar with this. When an event is detected, then during the time of that event, frames are scanned by the simple tracker by frame. So I think it was on this material was created on 15 frames per second. So we created the bounding box of every event within that video, and then we crop out those little images. They are of just 30 by 30 pixel size, something like that, and use that as material for training a neural network. So now the situation is an event starts and an event ends. And let's say during an event, for example, a plane comes in and it is only 1 pixel. And then it increases in size and it goes up to 20 pixels, for example. And then it vanishes on the next horizon and goes back to 1 pixel until it's no frame anymore. So the question now is, if we use Nicolas' approach and use a time sequence of images that belong together, then also a single pixel is a plane, because during the whole event it was always a plane. It was just far away, but it's always have been a plane. So Nicolas' idea is to train a neural network in that consideration that all images, all frames have to be considered as a plane or a bird. What Yannick is doing is it on a per image base. So Yannick, I'd say if you take that folder and we said to our labelers that they should take the whole track, if it is once decided to be a plane, take the whole track and drop it in. That is not good for a per image training, right?
Yeah,
Yeah,
I think so. I
yeah,
think that the per track labeling doesn't work out for this kind of AI model.
yeah.
Yeah, but currently it's possible for me to just double check the folder, and it's easy enough to see which images work and which images doesn't. So That's what I do right now, and I think that's fine. Actually,
Okay.
it's not too much work.
Okay. What I also found is we have several errors in labeling. So we have to work again on each folder separately.
Yeah, so as I
Maybe.
said, so we have a lot of images that are just empty sky, right?
Yeah.
Basically, for example. Yeah.
Christian.
May I interrupt
Of
for
course.
a moment? I have to take care of something here, and shall I just talk about in 1 minute what we achieved so far with the all-sky cam?
Okay, yeah. Go ahead.
Because I won't join afterwards.
Got
Okay.
it.
We got the QHY camera that we bought, and a complete unboxing documentation I will do in the next week. What I achieved so far is with any camera we have on hand, we can get pictures taken and put into the first in, first out buffer. But we have got a very huge delay by putting it into the WebSocket. I think I have to work on the WebSocket. It's now up to 7 frames per second. So I couldn't get any video streaming into it directly, and I have to work on that. But single frames, single images can be put into the FIFO and to the WebSocket, but not with 20 frames per second. So yeah, this is what I'm working on.
So your guess is the WebSocket configuration is faulty or what?
Not the WebSocket integration, but I think the interaction between the buffer and the WebSocket is not ideal. I have to work on that.
Okay.
But yeah, it's getting closer. And with a new camera on board, we have this camera can do 60 frames per second, but I don't think that we will reach that. 20 is
fair enough.
nice.
Yeah.
And is fair enough, yes.
Yeah.
So
what are you trying to get with 60 frames per second? Like, why do you think you can't get 60?
I think that the Pi isn't good enough to record 60 frames per second. Because its video buffer is limited too. And we're using the Pi 4 as a video buffer for the Jetson Nano, if we keep it up with. Because the Jetson Nano can't handle any camera with 20 frames per second with, let's say, 16 megapixels or above. And this QHY183c camera has, I think, 22 or 24. So if you want to get full frame, it can't do it. The buffer is too tiny for that.
Okay.
But I think I have to overthink the idea with the WebSocket and maybe find a much better one with configurable RAM or something else. But I'm on it. Yeah, I will figure it out.
Didn't you want to ask Rebecca about her opinion?
Yes, I'm going to do that.
Okay.
I wanted to ask in the discussion about it afterwards, but for now I have to take care of something.
Okay,
I'm
go
going
on.
to contact Rebecca, if it's okay with you, within the next days.
Rebecca, you heard?
Can you hear me?
Yes.
Yes, can you hear me?
Yes.
Yeah.
Okay, yes, that's fine. And I'm sorry if you could write down what it was you were saying as well.
Yes.
Okay, thank you.
Yeah.
Okay.
I'm going to talk to you about the WebSocket in the next week.
Okay.
Okay, sounds good.
Yeah. Okay. See
Perfect.
you. Bye.
See you, Christian. Bye-bye. So coming back to the trainings material, Nicola, I wanted to ask you something. You're working on the front end right now. Is it true?
Actually, I switched work on Neo4j to learn the syntax and how the graph databases operate, because that was the final idea for the Christian's server.
True.
And for data storage and data representation.
Yeah, true. Okay.
So in the past week, I was mostly doing the Neo4j, and I was experimenting with test databases, how to query it, how to mutate the data.
Mm-hmm.
And what I did regarding labeling, yeah, I changed because current software for labeling that I'm working on is using relational database, and I did change relations so that both track and image can be labeled on its own. So when you label a track, you are actually logically labeling all the images that belong to a track. So we can use it for transformers and recurrent neural nets. And I'm also having a relation for per image entity, so you can label image by image.
Perfect. That was exactly my question that I didn't even ask.
Now I'm because when we switch to Neo4j, I will need to rewrite my code. It's not really that compatible between relational graph databases. Its modeling is significantly different. So maybe I just, for practice, to work with Neo4j, I rewrite this software with Neo database. And then, because in the end system, we will have a lot of data and we will need to search this data efficiently from all the stations. And with graph database, we can do it. And I made a setup, a real quick setup, which is using Neo4j as a database and GraphQL as an API scheme, let's say. So basically now our API schema and database schema match one-on-one because both are graphs. So maybe from future standpoint, it will be better to have it like that because query flexibility is great.
Okay. Sounds good.
So, okay. I mean, if you guys have something more important, I can switch to that. But yeah.
No. This is perfect, Nicola. My question was just my question about the front end was just that you already answered. It's about when your front end knows about a track and knows about all these frames within a track, whether we have the possibility to label per track only or even on per image base. So we have two tags, let's say, two kind of tags or kind of tagging.
Yeah, but the visual part for frontend doesn't exist much right now.
Yeah, okay.
But in data model, it is supported.
Perfect. That's what I wanted to know. Perfect. Okay. So I think most of my points are already discussed, and we are short in the hour. Lila isn't here today. What a pity. I wanted to talk about the kinematics. So why not go back to, let's say, the 1.6 gigahertz topic? Because I think most of you are here. Or Rebecca, do you have any update for us?
Not really, not since last week, no.
Yeah.
I mean, you've seen what I've done this past week. I think I sent it in ClickUp and in the chat room. So no, I don't really have anything new. I haven't done anything since then. And I do try to, or hopefully I plan to put everything on the Sky360 GitHub tonight, perhaps, but don't quote me on that. And not tonight, then probably Wednesday.
Yeah. Perfect. Thank you. So, Ido, Matti, for example, it is not necessary if you report that nothing has been done in a week. So we are all sharing our time that we can share. And if we can't share, then that's all okay. So no stress upon anyone's shoulder here, okay?
I'm doing stuff. It's not really Sky 360, but I do have a robotic operating system working kind of between my computer and the Sky 360 Pi. It's working over VPN, so you don't need like direct connection also. I'm using some third-party for the VPN, but it's working pretty good. I have the hello world working, and also was able to create the GPS signal on top of ROS 2.
Okay.
So kind of create like the clock rate for everything. So we can do ordering and fusion in the future. But I'm still kind of looking on the implementation. I'm not really happy with how everyone implemented the GPS. It's missing some stuff, so I'm still digging into why and what they're trying to do with it. And I wanted this week looking how to take the camera stream. I have some cameras, small ones here, and one of my telescope cameras, and kind of just try to stream it over the ROS 2 platform.
Okay.
That is publishing it to everywhere, and then you can subscribe to it and do object detection, put the open CV on top.
And you do it like Christian does, or via WebSocket? Is that your idea?
So my idea is really to bring it as close as possible to the camera, and then take whatever the camera records, all the memory, put it on UDP, on as a ROS 2 message, okay? And then have another compute engine that actually will subscribe to those messages and do the object detection on top of it.
So like microservices inside of a box. So for each data source we will have.
Yeah, I spoke with Christian about it. I spoke also with Bojan about it. We can create the camera smarter, or even with one case we spoke about making the motor smarter. So instead of giving the PT commands move 2 steps, 5 steps, giving it a vector. So now you have a closer feedback loop, and it will the camera will move smoother, right? And it will offload also from the Pi or the Nano, whatever. Sorry,
the Jetson board, yeah.
Yeah. So it doesn't need enough power for that, and you reduce the latency.
Yeah. Yeah.
Yeah. So that's kind of the stuff I'm working on and thinking. Yeah, it's a lot of new stuff for me, so it's fun.
Yeah, that's the most important part.
Yeah. I actually got a GPS unit.
Yeah, which one?
Believe it or not, so it was on Amazon, and it's waiting here on the board. So I connected it, and this thing transmit nothing. Besides the time that I get from the I get sync from the GPS, it doesn't receive no events or anything like that. So I got what Christian told me, the USB one, and that works pretty well.
So you have a second one, it's a USB one, and that one works, okay.
Yeah, the USB one I was able to get with it a steady 40 hertz, but we don't, 1 hertz is enough.
Yeah.
And the ROS 2 platform is a real time, so it knows how to think about it how you develop games, when they create a virtual clock, so to synchronize everything, animation or whatever, right? A movement of players. So it has the same thing, but the way it does that, it synchronizes the clocks. So if you have a GPS in the unit, you have nanosecond kind of accuracy, right? So as long as we don't have anything that we collect data faster than nanohertz, we should be fine.
So you say
fusion, ordering, and yeah.
Yeah. So you say the GPS module is connected to the Pi because the Pi will act as, let's say, the master control program that has the clock.
Yeah. So we can sync the time. ROS 2 will be responsible for that. It does that internally, right? I still need to figure out exactly how it does that. It's kind of a blind spot for me. I'm not too familiar with ROS 2. It's new. But embedded in it, there is a deterministic framework. Okay, so whatever runs on ROS 2, when you ask for the time, you know exactly what passed. It's very, very accurate. Right? And yeah, I believe I need probably like to sync the time of the operating system itself, but I need to figure out exactly how it works.
NTP, or what do you use? I mean, we use basically Linux, so it's.
I think ROS 2 does the NTP.
Yeah, so.
Internally NTP, and then if the GPS update the NTP, then it's fine.
Yeah. Okay. So yeah, we have basically the backbone inside is Ethernet. So every you have the Pi as the NTP server, and every device subscribes to that as the server.
Yeah, so not exactly. ROS 2 already handles that.
Ah, okay.
Again, I'll read more exactly how it does that.
Mm-hmm.
But I don't think you need the NTP kind of system works. I think only ROS 2 probably needs it.
Mm-hmm.
But I'll figure it out.
Okay.
So that means that Nano will have also some kind of ROS bundle or SDK or something.
I'm sorry?
So that means if main ROS 2 is running on Pi, then we'll have some kind of ROS 2 client or something SDK on the Jetson Nano, so we can get the time.
You can run the ROS 2 embedded completely on SP30. I mean, that's
okay.
Yeah.
Nice.
So it's nice. The only thing you need is like an Ethernet port, right? And then I spoke with Christian, we can even do it like power over Ethernet. So the only thing you connect to sensor is the power over Ethernet, and you have the message bus already working.
Can we turn this upside down? I do not want to talk about power over Ethernet. I would like to talk about Ethernet via power.
Yeah, so that was the.
That's a different one.
That was the even more interesting conversation. Actually, got this one.
Yeah, TP links.
So it has two links. Yeah, it has two links. It's gigabit each.
Yeah.
I tested it. In my home. It's got around 800 megabit per one, which is pretty good. But if I'll get help how to hack it and use it as a Ethernet over power, that would be amazing. I mean, I like this idea a lot. That will work perfect.
But you already have it.
Yeah, it will be far more stable on DC than an AC, so it's good.
Yeah. I'm using this. My station is on the roof, and we have a terrace underneath. And when I'm inside, I can because it's all on. We have power on the same. So there's the same power systems, power grid, and I can just connect with these two TP-Link devices, and they run there in my outdoors actually since 2 years without any failure. And I can stream videos, and these are 8 megapixel videos I can stream flawlessly. I like that.
Cool.
It's a cheap solution for someone who only runs a power line somewhere.
Yeah. No, I actually believe this is the way to go rather than Ethernet, like power over Ethernet.
Yeah, absolutely.
Internally for robots.
Yeah, internally is okay, but yeah, power over Ethernet is critical when you load too many devices on it. You get very high peaks of amperage.
Yeah.
On a line that is not meant for that. All right. Yeah. Any questions? Any topics for now? I think I'm totally through my topics here. So we can have an open discussion if you prefer to. If you allow me to, I go back to the 1.6 gigahertz misery, because.
Why would you get that again?
Pardon me?
A 1.6 gigahertz misery? What's the? This is
What's
Because we
the
don't
name?
know what it is.
yeah,
Oh,
this
Gotta
is
okay.
get to
called
It is a misery, isn't it? I mean,
it's a headache.
it's maybe it's not a misery. Maybe it's simple and it's just satellite communication. Mystery. So my question, Bojan, is actually you are testing some software now. Is this software capable of checking for modulations? Does it analyze the signal somehow?
Yeah, let me share my screen, and I like it. I test like let's say 5, 6 softwares, original software through the MATLAB, and this software name is SDR console. Let me share my screen, and this is it has still learning, but it has a lots of features, you know. So I think this is good way to go with. I mean for me. So what I'm going to do when I receive this PCB quadro helix, and I'm going to make and mount on the Maxi, and because I worry about Vagrak knows about it, and he was talking about it, the mirror, moving mirror. So I'm going to mount the helix antenna. I'm gonna redo the stand, and will be like, pointing this way, and I will test how this mirror inside the Maxi interfere with antennas and stuff like that. Because Vagrek saw I bought this VNA network analyzer, antenna analyzer, and he said this is okay, and I mean for this kind of money. So allow me to check it out, because we have motors, we have all bunch of stuff inside. So it is very important, to have kind of, antenna, but other devices not interfere with antenna and whatever, amplification, whatever. So this is I'm going to do right now. I hope in next week I will receive. I ordered this silver copper wire, and then I will make. I have like a 4 boards that I order, so I will experimenting with this. So we'll see.
Okay. Okay.
What is Wagrick talking about? If you around, if you wrap it up, the helix antenna, this is too big diameter.
Yeah, you cannot change really that diameter.
Yeah. So if I wrap it up, not gonna work because diameter is too big.
Well, if you make it a wideband antenna,
What is it?
if you make it like a wideband antenna, wider bandwidth helix or something like that, like I linked that with like a very wide strip of copper.
Yeah, actually he sent me white paper about 1.1 turn stripes.
Yeah, it doesn't have to be that like 1.1. It can be like 3 turns or more. But the idea is that you increase the bandwidth of the antenna by making the strip like wider. I actually made at least one of these kind of antenna like 10 years ago.
Yeah.
But anyway, so it
Go ahead.
yeah, of course the material of the telescope will have an effect if it's very lossy, but if it's plastics,
Yeah.
it have a minor effect. But if the mirror is, for example, metal coated, I don't know if it is.
It's glass. It's a glass mirror.
Aluminum?
No, it's a glass mirror.
Okay.
Glass mirror, yeah.
Yeah.
And it's moving, it's moving, moving from like at this point to this point, and this can affect antenna,
Yeah, so it definitely has some effect, but it's really hard to say. without testing how much effect will have. But I'm afraid that okay, it's not a commercial antenna anymore. But if you don't have any space for it, then that is the only way to go basically. If you could mount it on the top of the tube or something like that, like usually you can mount your. I have this small telescope that you can mount a camera on with the lens on top of that, for example, and still the motorized mount can handle it. But of course it will affect on the balance and stuff like that.
Hey Bjorn, why use such a big coil, big round diameter coil, as opposed to like copper tape?
No, I'm going to try copper tape.
Yeah, exactly.
That way you could put it on the inside.
No. Please do not put anything in the inside.
It will reflect, basically.
Yes.
On the inside of the body, it'd be real thin.
Yeah, but you see...
Reflections.
It has to be black.
It has to be black.
Okay, good.
And,
as black as possible.
Yeah, I get it.
And the telescope doesn't exactly come apart easily and go back together easily. So
yeah. Matti, I have another question too. No, we do not infringe the scope, please. We do not. Matti, I have a question to you. You proposed an antenna that's called the Vivaldi antenna, right?
Oh, well, I think Bojan has already had an idea that we can use that. It's a basically wideband antenna, and you can have those kind of. I think I have linked at least one company that sells those in Amazon. Very nice antenna, basically. But the problem with those, there's a quite high gain and wide bandwidth, like from 1 gigahertz to even up to 12 gigahertz. But the thing is that they don't work that well on the lower end of it. So,
can we create our own Vivaldi antenna?
Yeah, of course, and there's plenty of choice on the Amazon already. But the thing is that it has to be quite big if you want to go like a below 1 gigahertz.
So now, if we talk only about the L band, how big would that antenna be?
I can check the things that are already available, but I don't know really what the maximum size is.
Or the minimum size?
Yeah. But that would be a wideband and with the reasonably high gain, like up to 10 dBi or a bit more. So it's like with the helix you can have similar gains, but it's not that wideband. So the idea that I don't know have you chosen your receiver already? What's the bandwidth of that?
Yeah, already I did some, like for 1.6 gigahertz on a site. If you see my screen, right?
Yeah.
Let me see. Oh yeah. That's a Vivaldi.
Yeah.
Is this now in your point of view a big one or a small one?
This is for 1.6 gigahertz. Mid frequency. Can go, I don't know, 1.5 gigahertz, something lower.
Okay. So you calculated that with a software that creates that?
Yeah.
Okay. Okay. MATLAB can do that.
MATLAB has software so you can design antenna regular, and then you can have a design. You can you are able to design PCB antenna.
Yeah. Okay, but the geometry is calculated for the 1.6, the L band, let's say. Okay.
Yes.
So I'm looking at that little SMA connection on the back of that thing. Where does that go?
My idea, because we have Jetson Nano in the PZ head, right?
It's on the side though.
What I'm going to do next week when I receive this, and then I'm gonna send this antenna to make this new audio on a PCB, and then load the software and SDR software on a Jetson Nano and see how this works.
Okay.
So how are you getting the SMA connection into the Jetson now?
Cable.
Well, yeah,
a USB drive, a dongle, a USB dongle, kind of.
Yeah.
No, antenna going to the USB dongle and USB dongle going to Jetson Nano.
Yeah.
Or Raspberry Pi.
But you've got SMA connection. I'm using the GPS for example. You're gonna have oh, actually, I have a dongle here. You're gonna have this thing stuck into your USB connection, and then you're going to have this wire doing this all day. As it,
This will be achievable. I don't see any problem. I don't have any.
So first of all, Brett, the cable will be longer because the distance between this connector and the electronics is certainly 30 centimeters or so. So there must be a longer cable.
It's not my concern. It's just that.
Yeah, moving. But it won't move at that point. It won't move at that point because the electronics are, we're talking about the PT set. So the electronics are on the side walls of the PT set on the outside. So they are fixed mounted, and all cables that go from them towards the camera and yeah, this cable is fixed at the point where it leaves the board. So the only thing that moves is, in that case, because horizontal, the whole thing moves with in horizontal. So there's no horizontal, it's only vertical movement. And for vertical movement, it's 90 degrees, and the distance of the cable is about 20, 30 centimeters, going 90 degrees. So yeah, that's the banding of a cable. It's certainly not inflicting the board. Whether the cable wears off over time, we have to see.
Only my concern, PTZ cannot spin like that. Must be 360 degrees back and forth.
Yeah.
Actually 180 degrees back and forth. In order, if you're spinning, then you can have problem with the cable.
Yeah, but we are spinning. We're spinning, the whole PT set is spinning. So the board and all the cables are inside already, the PT set, are spinning with them.
Yeah.
So it's the local geometry, local coordination.
No problem with that.
Yeah.
So there are many different size cables. The longer you get, the less stress, the less friction you have on it.
No, I don't see any problem.
Just get a 1 meter cable, or this is actually a 1 foot cable.
Is it stiff or is it soft or stiff?
No, it's flexible.
It's flexible.
Just like what he's got, but longer.
Yeah.
It's exactly what he's got, but longer.
Flexible.
Perfect.
Just along the snag.
Yeah.
From all of that motion.
No, so what you bend here, it would never happen. So much bending.
Okay.
Because it's so long and yeah, the travel distance. Matti, is Matti still here with us?
Yes.
Matti, are you there? Vagrak? Yeah, okay. Okay, you hear me. The antenna that Bojan showed us, what do you think such a Vivaldi camera? Because it's now fixed to the scope, and it will turn with the scope, pan and tilt, because Bojan designed it now as a sidekick to the scope. What is the characteristic of that antenna? How much field of view, or how do you say in SDR, the field of the characteristic? Can you give us an idea about it?
Yeah, well, it's on top of my head. It's again, it's like a 10 dB, so it's like a was it 60 degrees or so. The beam width. So in order to have like a really pinpoint, you have to have gain like more than 30 dB, and that will definitely require a dish. antenna, like a parabolic reflector, in order to have like a few degrees.
Yeah.
Like a.
When you say 60 degrees, is this 60 degrees, let's say, in the picture that Bojan shows us, is this the vertical field of view?
Roughly, it's similar vertically and horizontally. It's like a.
Oh, really? Okay.
So, but one thing for this kind of antenna, so this is linearly polarized antenna, basically. So it will receive only one polarization, linear polarization, and the helix antenna is a circular polarization. So it's actually can receive a circle and also linear polarization with the decent amount of loss. So in that sense, the helix is better choice. So basically, you would need to have two antennas perpendicular to each other to receive both polarization angles.
Got it.
Because we don't know the polarization of the transmitter or whatever is it.
Yeah.
Meanwhile, the antenna is better to use like for antenna array for radar.
Yeah,
so,
it's actually used for array. Yes. A lot.
Yes, and I mean, since we in a basic station we using 5-channel radio, right? So we can use, 5 channels, or you can mix antenna 5 or 4 without the antenna in order to get this radar.
But
You've got a number of USB ports, by the way.
No. You have 5 antennas, and then you mixing, but this is different issue. You mixing the 5 signals, and then you have one signal going into one SDR radio, right?
Well, that's possible if you have a switch or a deflector or something like that. But with the switch, you can have one active antenna, and you will switch the, which one is active. Or if you have a different frequency bands, then you can combine those with the to one.
Which is good idea.
Yeah. But different ways to achieve it. But was it that the Kraken SDR has at least 4 or 5 channels?
5, yeah.
5,
yeah.
So it's intended for the direction finding. You basically need at least 4 channels for direction finding, and for passive radio, you need at least 2, usually 1 for the actual illuminator and 1 for the searching for the reflections, I guess so.
I thought you needed to have, in order for further distance, you needed to have more of a larger antenna, more of a parabolic. So yeah, like one thing.
Yeah, there's a different, but I don't know. with the low end budget, I would say you have to have at least like one omnidirectional that is listening the whole bandwidth of the receiver and scanning it. If it detects something, you can then use more directional antenna to have at least some idea where it's coming from. But again, like reflections will play a big part. If there's we don't know the environment of the where the devices are. If there's some reflecting material nearby, so it can detect the reflected signal, not the the direct one. So plenty of difficulties with the direction finding. But usually, if it's on the pointed to the sky, the reflections are not that fast. But if it's in a low angle, then it's going to be more difficult.
Yeah.
Yeah. But at least something can be done. They're quite low budget. That Kraken receiver was quite interesting.
I guess we could test it by the airplanes that are going by, because they go altitude of 40,000 feet. So if we can point the PTZ at an airplane and pick it up, then we know we're doing some good. If not, then we know we're not strong enough or weak enough, sensitive enough.
Yeah.
So may I bring us all on the same table, because I think we derailed a little bit. So we have three topics what RF is meant for. We need passive radar, because some things do not show up on the visual. And we have ADS-B, because we have to kick out all the known planes. And there is the L-band misery. So my question to all of you is, how many channels do we actually need to do passive radar, to do the L-band, and to do ADS-B? Or put ADS-B totally on the side for a device by itself, for example. Can we use the Kraken to solve passive radar and the L-band misery? Or shall...
So if it has a 5-channel, I have to check.
Yeah, it's a five channel.
Yeah, so you can basically use it. You don't have to use their code and the direction finding mode. And you can use it like 4 independent devices, basically. So there's lots of options.
Yeah, but for passive radar and for direction finding, we need at least 4 antennas, right?
Yeah.
Okay.
Or maybe 2 with passive radar. I don't know. That's quite minimum at least.
Yeah, I'd say for a triangulation, I mean, for 3D triangulation, we need at least 3 or 4. So that leaves us with 1 over. But with 1, we can only do an omnidirectional antenna, let's say just 1 antenna that focuses in the L-band. But we could not add another one that is attached to the scope. So my question is, shall we separate the passive radar and Kraken device from ADS-B and from the L-band? Shall the L-band be its own system? You know what I'm heading to, Tommy?
Yeah, I agree. Because you're just trying to do research. You're just trying to search something out, as opposed to something you already know. So you can, I would say, yeah, because you want to learn one. You want one device to be your main unit that you're going to teach. You're going to say, hey, we want you to focus on these. The other is you're just searching anything you can find out there. Total 2 different tool sets.
True, yeah. So I'd say we keep the Kraken for passive radar, and we do I don't know, a Pi with a no-ALEC dongle and do the ADS-B, and let's do the L-band with whatever you guys come up with. To separate those systems. And for the L-band, let's say, first of all, I would not go for a directional antenna for the 1.6 topic for now, because I'd say we should first find out whether there is a topic at all, whether there is something in the 1.6 we have to look after. Because when it all turns out to be satellite communication, we can just drop it, So let's start just with an omnidirectional antenna for the L-band and see what kind of modulation or signal properties we can find out.
Well, I have some ideas. I just want to talk to Maddie first before we carry this conversation any further. It's specifically about antennas and about the way they're made and the way that we should approach this situation. I just wanted to get his opinion about it as well before we went any further. It's just a lot of, like the way that they're made, for example, how the way we're approaching it. the materials that we use versus you know, what's available out on the open market for people to use, things like that. I just think we need to have a more in-depth conversation. I was going to do it all in the L-band channel, so that we all can see what's, you know, what's discussed. But it just take it off topic from here, from this discussion.
Okay. Okay, yeah. Let's do that on the L-band channel, right?
Yeah, because we'll talk about the SDRs that we want to use and whatnot. I have some ideas as well. I want to organize it. That way we're not all just throwing stuff out there and it just goes nowhere.
Yeah. But your idea was to have 3 locations on the planet that do the same tests? Okay.
Yeah.
Perfect.
With the same equipment. That way,
yeah.
Because the stuff that I'm using, one of the things I was going to share with him was we finally are coming out with the economy version. I had told you earlier in the year that we had the base unit, the RS-250 spectrum analyzer, but it's like $4,000. Well, we came out finally with the economy version, as we call it, and it's like $2,000. You know, list price.
$4,000 is not a lot for spectrum.
But when you're trying to get the mass public to buy it, it's a lot of money. And that's what I'm talking about here. And yeah, there's going to be strategic locations that will have these things that you'll definitely want the better unit. But what I'm trying to do is we've got this really awesome software that does 3D waterfalls that better than anything anybody has ever done before. And the reason why is because we built in the speed, the bandwidth that you need to be able to build these actual models. And before, everybody was working off of 80 megahertz real-time bandwidth. And we go up to 245 now, which is like lightning speed. So the models that it builds is really precise. Whether it's a bad model or a good model, you know, whether something is a good signal or bad signal, it just does it so well. And you're able to see things, you're able to pick things up really quickly. And so I'm thinking that some of those type of tools is something that will be necessary. SETI agrees, and that's what they're going to be using. And same thing with Skinwalker Ranch. So I think we should be following suit with the same type of tool. Not to say that we can't use the SDR, the Kraken, or whatever. I just think for the in-depth stuff that we're trying to achieve, these are the types of tools we need without going to $100,000, you know, spectrum analyzer.
And what kind of devices are you focusing on for these 3 locations?
So I'm thinking that we do an omnidirectional antenna with a directional antenna. So like the one that I just sent to Ozzy and to Bjorn is it goes up to 10 gigahertz bandwidth, and then or frequencies, and then it's a directional finding, but it's a very professional directional finding, so it's very accurate. And then of course the what will follow suit is possibly I have to have another meeting tomorrow with the developers on what is actually going to be released on this economy version. But I think
is there? Okay.
I think I'll be able to get these out right away to both those guys, so that we'll have me in Texas, one in Florida, one in Australia. I want to go further with that. Right now I think we ought to go slow and see what we find. And then if we get something out of this, then we go even further. You know, we just start adding more. But the fact that SETI's going to have one in Las Vegas next to Area 51, one at the observation in the West Coast in Huntington Beach, California, where they've got the observation deck there now. It's actually another city. I can't think of it off the top of my head now, but it's right next to Huntington Beach. So they'll have the same analyzer there as well, same software, same technology.
Okay.
Yeah. So I think that will give us a good triangulation between us all. And then, of course, Skinwalker Ranch, when they finally install theirs, if we can't find it then, I don't know what to do.
Okay. Hey, Yannick, goodbye.
Yeah. See ya.
See you. Take care.
The funny thing, we don't know what we are looking for.
Well, I'm thinking with having SETI on board and Skinwalker Ranch, it will lead to a lot of good questions. Maybe a lot of good research, because they don't have all of us, right? Now we're a much larger team to make something happen here.
Yeah,
True.
let's get synchronized,
Yeah, exactly.
Yeah. Yeah, cool idea, Tommy. Absolute cool idea. These are things we should do in the future as well. Not only developing stations, but also going down into this phenomenon. And I think this is at least one of my ideas. If in the future we come up with new technology that's being developed, invented, we should test it and see whether it helps the purpose. So for me, this project is not ended when we did it. For me, it's an ongoing process.
Yeah, I agree.
Hey, Tommy, what SETI said, SETI people think about 1.3 gigahertz, if any.
He honestly, God, he acted like he hadn't heard of it, didn't understand where we got it, how we got it. So I explained to him to go watch season 3, episode 6. Told him watch 5, 6, and 7, Skinwalker Ranch, just to see what they're talking about, right? So you kind of get a concept of where this is coming from, and so yeah. Now, I'm supposed to have a meeting with them this week, so I'll find out a follow up to that.
Yeah.
Okay, cool, good stuff.
But I'm going to also arrange it for next Sunday for him to talk to us next Sunday.
Just I was sharing. Can I share just quickly one more screen? What I have from FCC. You see this this area has nothing right here.
Where did you get that one?
I will send PDF to one L-band channel, so you can read about.
Okay.
So this white area is for something, if any, and
Okay.
this is 1.6 gigahertz. So I don't know.
Yeah, someone produced this PDF to explain to someone else what's going on around there.
By FCC.
So then the FCC has all kind of PDFs for any kind of band overviews, right?
Yeah.
Okay.
Because if you're going to do something to broadcast or whatever using some frequency, you gotta ask FCC to agree.
Yeah, of course.
Yeah. So this is kind of good guideline. What's going on. I mean.
So what is ligado actually meaning?
I don't know. I'm gonna send PDF. I didn't. I was just look what's going on here. But on a PDF you have good explanation what's going on.
Matti, do you have any idea what ligado means?
I don't know.
I just did a quick Google search. It's Ligado Networks, formerly known as Lightning Squared, American satellite communications company.
Ah, okay. And only for one company?
Yeah,
that may be
just
free.
everything for them.
It might be just data that he downloaded from them only, that's all.
Ah, okay.
We don't know the source that they got that.
Yeah, true. Yeah, but Bojan, you said you downloaded it from the FCC. True?
I'm sharing now on a L-band.
Okay, but you downloaded it from the FCC, right?
No, this is like a www.selectspectrum.com.
Ah, okay.
So I share.
Yeah, but it could, as Tommy said, it could be produced from the company Ligado.
Yeah.
So I don't know.
Yeah.
You got it?
Got it. Maybe we can then contact the company Ligado and say, what kind of modulations are you using? Please just tell us. Not the protocol, just the demodulation. Would that help? Or is it a stupid question?
No, it's a good question. They may not answer, but it's a good question.
You think they might not answer? You sure?
They say it's RC. Well, if we're not a customer, they may like, hey, who are you?
Well, you can try to be to do like becoming a new customer. So the only thing I'm interested in your device is, can you tell me your modulation? If you can't, I'm not going to buy.
Pardon me, sir. What are you transmitting?
Nothing. I'm receiving only.
Say, pardon me, sir. Do you know you're leaking 1.6 gigahertz? Because there doesn't seem to be anything modulated in it, so it's got to be a leak somewhere, right?
You're wasting energy on your sets. Could be. But must be a strong signal as well, doesn't it? I mean, can anyone give me an idea how strong that signal must have been if it comes from a satellite, so that we can receive it on ground with such a peak, with such a decibel?
Yeah.
How much power is necessary for that? Matti, can you give me an idea how much power is necessary?
I think GPS is then, but it's much, it gives what they are. It depends on how close the satellite is.
Yeah.
And it needs watts, tens of watts, at least for the GPS, because it's like a 13,000 kilometers away or something like that. But it really depends. I can do some calculation if you need to.
No, it's just a question from interest.
But,
and then the question is it coming from the ground or is it coming from the sky? Because if it's coming from the sky, it's going to be less wattage that you need than if you're trying to transmit up and then back, or transmit linear.
Yeah, but it can be, caused by interference from the almost anything basically.
So if it's coming from ground, it has to be close, right? Matti, are you saying that?
Yeah,
because of the atmosphere, I would say so.
Yeah, but I don't know your data basically, so
yeah.
Prefer the common because there's a lot of like a cellular stuff going on, and there's some intermodulations and all kinds of non-intentional interference around us. So it's quite easy to catch on that. But I don't know your setup in any detail. Cannot really say very specific.
Matti, Tommy, would it make sense to you so that Matti takes the same equipment like Ozzy and Bojan to test it in Finland? Would that make sense?
Yeah, without question. No, I already planned to hook all that up. Yeah, absolutely.
Okay, great. So Matti, would you contribute your time in testing that? So if Tommy sends you the setup, the hardware, would you be able to find time to test it and to see what you can find?
Yeah, of course.
Okay.
I don't. With L-band, this year it's quite crowded with the telecommunication, but yeah, I can check it.
Yeah, because it's interesting to know. We don't want to just look at the United States. We need to look all over the world.
Yeah.
Because
I have some possibility to use some equipment from my work, but I don't know if you already got some references.
Yeah, we want to try and keep everything the same if possible. I mean, it doesn't hurt to do it with different systems. Just it'd be nice to have them the same.
Sure, yeah.
Okay, sounds good. So guys, any other topic for today? Otherwise, I'd say we wrap it up. And yeah, if no other topic, Bojan, no new topic. Okay, perfect, sweet. Okay, guys, I stop recording now.